Good evening everyone. Welcome to this session of Graphical Method 1. Last time we had a discussion about understanding basic and non-basic variables, and we are going to extend it to understanding of why we use graphical method and its applications. All right. I hope you are really doing great out there, and a very good evening to you. A very enthusiastic good evening to you. Now, this is about me. My name is Rahul Kanyal. I have had an experience of around 2.2 or 3 years in BHEL. Then after that, I went to IISc Bangalore and did my master's. And here I am in front of you delivering these lectures and all. Okay, fine. Now, last time we had a discussion about the basic solutions, and we also understood what an objective function is, and we were there solving maximization of profits, right? We also said that we could also solve minimization of costs as well, right? Yes. So let me recap it, what we were trying to do. We were trying to maximize, okay, maximize z equals to twice x1 plus x2, okay? And we said that there are constraints associated with z. Z can be, let's say, profit, because we always want to maximize the profit. Yeah, this is subjected to constraints, because why do constraints come in? Because not everything is perfect, right? So we said that, okay, x1 less than equal to 2, x2 less than equal to 1, x1 comma x2 is greater than equal to 0. This was what we had done. So how did we proceed? We said that, okay, we are going to plot these inequalities, these constraints. Then we went ahead and plotted these, right? And let's say this is 2 comma 0, let's say this is 0 comma 1. So this line is x2 equals to 1, given that this is x1 and this is x2, right? And this line is x1 equals to 2, right? This is what we said. Okay, fine. Then we say that, okay, then the inequalities of x1 less than equal to 2 means that it is referring to the left hand side of this, fine. And x2 less than equal to 1 means that it's referring to this bottom side. All right. Then we say that the common region is this one, and this one is called a feasible region, right? And we get 4 corner points here, 0 0, 2 0, 0 1, and this one should be 2 comma 1, right? And we said that out of these 4 points, we can maximize z. And we said that, okay, at this point z at 2 comma 1, we were getting maximum value of z. So 2 into 2 plus 1, I just put in the values of x1 and x2 in this. So what do I get? 5. So we said that this is the solution. What is the optimum solution? x1 equals to 2 and x2 equals to 1. And optimum value of z is 5. This is from where we calculated it, right? This is coming out to be 5. Optimum here means maximum, because it's a maximization type problem, right? This is what we said. Now we also said that the concepts, we also went through the concept of basic variables. We wrote this equation like this: x1 plus s1 equals to 2, x2 plus s2 equals to 1, right? And we said that s1 s2 is greater than equal to 0. Okay, fine. Now I'm going to take you to very basic concept, because unless you know plotting inequalities, you won't be able to solve a very easy question in GATE or ESE. Okay, you can get very easy 2 marks, and believe me, a coaching is about those 2 marks. Once you get 2 more marks in any examination, your rank soars high, isn't it? It makes a hell lot of difference. So this is what we are here for. We are trying to solve a very easy problem here. So for that, we need to understand how we plot inequalities. Okay, fine. So let's say this is x1, let's say this is x2, and let me plot this. x1 plus x2 less than or equal to 1. All right. So what we are trying to do here is that, firstly, whenever an inequality comes up, we need to plot the line. First step is plot the equality, that is x1 plus x2 equals to 1. Firstly, we'll plot this, right? To plot this, firstly we'll put x1 equals to 0, which means x2 equals to 1, and put x2 equals to 0, which means x1 equals to 1. So we have gotten 2 points. The point here is 0, 1, and the point here is 1, 0. So let's plot these 2 points over here. 1, 0 and 0, 1 should be here. So this is the line. Okay, this is the line. x1 plus x2 equals to 1. Now how do you plot this? x1 plus x2 less than or equal to 0. Now second rule is that make the coefficient of x2 positive, then choose the side, top side or bottom side. Okay, and let me tell you that you will score a good rank once you understand the concepts. Okay, it doesn't go the other way around. You firstly understand the theory part. That's why all this. Fine. So we are going to understand very basics of it, because in examinations only the basics come up. That's why we are here. All right. So just hold on. If you already know this, we are going to get ahead. Okay, fine. So now what did I say? I said that make the coefficient of x2 positive. It's already positive. Now check for the sign here. Sign is less than or equal to. That means we are talking about this region, lesser than region, right? Because here we have less than or equal to, so this bottom side comes up. Okay, all this region is corresponding to x1 plus x2 is less than or equal to 1. I hope I'm making a point over here. All right, yes? Okay, fine. Now let's say this x1 minus x2 is greater than or equal to 1. How do we plot this? So firstly we plot the line. Plot x1 minus x2 equals to 1. Yes, can you plot this? This is x1, this is x2. Similarly, we need 2 points to define a line, right? So that we connect them and then we get a line. Okay, then we say that fine, this is 1, 0, and when I put x1 equals to 0, so x2 comes out to be minus 1. So this is 0, minus 1. So this is the line, right? I hope you know how to plot the line, right? Okay, fine. So x1 equal to 1 and x2 equal to minus 1. Yes, fine. Now what did I say? The next point, you have to make the coefficient of x2 positive. And before this, let's say 2 is greater than 1, then when I multiply this inequality by minus, what it becomes? Minus 2 should be less than minus 1. So what it means that if I multiply an inequality with minus, the sign of inequality changes, as you can see here, right? So I'm going to write this inequality as minus x1. I'm going to multiply this inequality with minus because I want to make the coefficient of x2 positive. Yes, so minus x1, okay, there's a bit of interference here. Minus x1 plus x2 should be less than equal to minus 1. Yes, now this sign you have to see, this is less than equal to sign, so it is the region given by this, the bottom region, because the sign is less than equal to. Yes, yes, all right, okay, fine. Now we are just, Amol, we are just trying to plot the inequalities, that's all. We will see its application. Okay, fine. Is that good? Okay. Now let's see types of solutions in this. Okay, number one is unique solution. Unique means just one solution will get. Okay. Number two is infinitely many solutions. Number three is unbound solution. Number four is infeasible solution. All right, infeasible solution means no solution. Fine. Okay, now let's see few examples straight away. Okay, see, this is a question, this is a question from GATE. It's a very easy question, a 2 marks question. Anyone can score in this. All right, so let's plot this. First thing is that you need to plot. Okay, so what it is asking for the type of solution, and let's try to understand them through examples. The best way to understand them is through examples. So firstly, let's plot inequality 1 and inequality 2. Is that good? Okay, so I'm going to plot it here. Let's say this is x1, let's say this is x2. So firstly I put x2 equals to 0. So what do I get? x1 equals to 3. Yes. So first point is 3, 0. Yes. x1 equals to 0 when I put, then I get x2 equals to 9. So I get the next point over here, 0, 9. I combine these 2 points like this. Doesn't seem to be a very straight line though. Yeah. Let me do it again. Yeah, that's better. Okay. Okay, Satish, will just hold up. We are coming to the point. Okay, it's really great that you found an answer. I really congratulate you. Okay, fine. Let's see. Okay, so this is how it will look. Is it visible in the green background? Okay, fine, let's try to do it, and this is how it will look. Now, okay, the coefficient of x2 is already positive, so which side should I go, upside or the downside? Because it's already positive and it's greater than equal to, then this is what it is referring to, this region. Okay, and because x1 x2 are greater than equal to 0, we are talking about first quadrant only. Everything will be, yes, Satish, you're right, it should be up. All right, yes. Now let's plot this 12x1, this is the first line. Let's plot this 12x1 minus 6x2 is equal to 24. Okay, let's plot 12x1 minus 6x2 equals to 24, because the first point is plotting the line, right? So what are the points that I'm getting? 2, 0 over here, right? And let's say this is 0, minus 4, right? So this is the line, this is the second line. All right, now should it be upward? Now let's plot this. Because the coefficient is negative, we need to make it positive, so this can be written like minus 12x1 plus 6x2 is greater than equal to minus 24. Yes, I'm just going to delete this to improve the visibility, and because it's a greater than equal to sign and the coefficient of x2 is positive, so it's upward or downward? It should be upward, right? So what is the common area for that? Common area is this region. Right? This is the region. So is this region bound or unbound? Is this region bound or unbound? Bound means any region with boundaries is called a bound region, and this doesn't have boundaries, right? It's open from the top. Yes, Satish, you're right, this is unbound. Okay, yes, so this might be the solution for this. Sharmila, yes, you're right, this is unbound, so this might be the solution, but there's one more condition for it, and the condition is because this is unbound. Okay, just listen to it. Okay, this is very important. x1 tends to infinity and x2 also tends to infinity, because this is unbound, right? Agreed? This is unbound, and so this is going to happen. When this is going to happen, and when we are talking about maximization of z also tends to infinite. Agreed? I think I'm making my point. Okay, x2 takes positive. X2 means the second constraint. Sharmila, are you talking about the second constraint? This one. Reply. I'm waiting for you. Sharmila, I'm asking you, okay, why x2 takes positive? I'm not understanding this question. Can you reframe it? Then I'll come back to you. Okay, let's move ahead. So when this is happening, z is also not defined. Okay, this is the condition that you need to make the coefficient. I'm replying to Sharmila. You need to make the coefficient of x2 positive. Okay, so to make the coefficient of x2 positive, you need to multiply it with minus. This is what we get. Then when this is positive, then see the direction of or the sign of the inequality, that is greater than equal to. That's why this is going upside. That's why. All right, this is how it is done. This is how we plot the inequality. I have explained it. You can go back and watch the video once more. Okay, so for now just accept this. Fine. And this is also the condition. When Z is not defined and the feasible region is unbound, then only we say that it's unbounded solution. It's really very important, this condition. Okay, fine. Now I have a question for you. What if this is minimization of Z? Will it still be unbound? Will it be still unbound? This is the question. What do you think? See, obviously the feasible reason is, Sharmila says no. Okay, yes, she is right. Why? Why, Sharmila? Can you please elaborate? Can you please type in there? Why is it that you think that it's not unbound when I convert this to minimization type? We have to check, because see, it's very easy. See, it's very easy because here this is the condition, right? If we say minimization type, then we are getting two corner points over here. First one is this one, second one is this one. Yes, yes, this is not going, the function is not going to infinite or unbound when we are trying to minimize it. So out of these 2 points, one is going to be the optimum solution if minimization is done to Z. Okay, this is what I mean. Then you can calculate it. Okay, you can calculate this point by intersection of these 2 lines. This is already calculated. At these 2 points you will find the value of Z, and I hope that it is very clear to you. Is that good? Is it good? Okay, fine. Okay, this is also from GATE. Okay, now let's move ahead. Okay, find the type of solution in maximization of Z equals to this. Can you please find it? This is also from GATE. Hari says that if it's minimum, it's bounded region. See, the region is not bounded. Okay, so you're asking, see, the region is never bounded. Okay, it's unbounded, but this is the condition to be called an unbounded solution. Okay, so if we say that minimization of Z, now can you please find this point if you want to solve this? Can you solve these 2 equations? 12x1 plus 4x2 equal to 36. 12x1 plus 4x2 equals to 36. 12x1 minus 6x2. 12x1 minus 6x2 equals to 24. 24, right? So can you solve this? Can you please solve this? Quickly, can you please solve this? Please solve this. Okay, because yeah, even I have my calculator. Let's solve this quickly. Equation minus 2 minus 12 minus 4 36 12 6 4 x equals to 2.6 x2 equals to 1.2. Let me again check it if I have input the correct values. Okay, so I'm going to just check it once if we have gotten the correct solution. Okay, fine. So this is what we are getting, 2.6 and x2 equals to 1.2. Okay, yes, fine. So x1 equals to, what was it, 2.6 and 1.2. Okay, so this is 2.6 comma 1.2. Yes, now what you need to do, you have two corner points. Yes, it's fine, Satish, we all make mistakes. Okay, so what you need to do is you need to find the value of z in these 2 points, that is 2.6, 1.2 and 0 comma 9. Okay, so 15x1 plus 20x2. So z is 15x1 plus 20x2. Find z at 2.6 comma 1.2. 15 into 2.6 plus 20 into 1.2. Find this. And what was the another corner point over here? This point, right? They're just two corner points, and we have derived that only in corner points we get the solution, right? So can you please calculate this? This one and 0 comma 9 is going to be 4 into 9. Or let me not eat it. So 12 into 0 plus 4 into 9. How much are you getting? This is 63. This is 36, right? No, it's at 0 comma 9. The first one is it correct? 63? Which one? Which one 180? This one? This is at 2.6 comma 1.2, right? 2.6 comma 1.2. x1 is 2.6 comma 1.2. So let me 15 into, okay, you're saying that 20 into 1.2, it's 63. This is fine. This is fine, right? Okay, now this, just put x1 equals to 0 and x2 equals to 9. That's all. There are just two corner points out there. So this is what we'll get. Right? First equations of z equation. No, but this still goes to 0. Okay, fine, yes. I had done a mistake. You're right. Just hold on. This is, z is this, so this is 15 into 0 plus 20 into 9, that is 180. Yes, you're right. I got confused over here between this and that. Okay, good. Yes, you're right, Satish. Very much right. Okay, fine. Now, which one of these is minimum? This one is minimum. So, x1 equals to 2.6 and x2 equals to 1.2 is the solution. Solution, and minimum value of z is 63. Okay. Is that good? Fine. Yeah. Okay, let's move ahead. Okay. let's move ahead. So the point to be understood here is that if it's unbound, it need not have an unbound solution, as we saw here. It's very important, you need to grasp this. Okay, yes, fine, good. And now can you please try to plot this quickly? Just plot this quickly. Okay, just plot this, these two inequalities, plot them. This is the first, and because it says less than equal to 6, okay, so x1 equal to 2, x2 equal to 3, right? So it will be the bottom, this area, right? Because this says less than equal to 6 and the coefficient of x2 is already positive. Yes? Yes? Okay, now this one, no, we don't have solution for this, Sharmila. Actually, you just need to find the type of solution out of the unique solution, infinitely many solution, unbound solution, and the fourth one, infeasible solution. Okay, so firstly we are just going there, just hold on, we are just going there and we will see what this solution looks like. Firstly you need to plot this. First point is plotting. So plot this. The number one thing is like this. Number one inequality is like this. Number two inequality is like that. Yeah, so last question. Okay, Sharmila is asking what was the type of solution in the last question. Okay, so let's go back. If I converted it to minimization type, so the type of solution here was unique solution, because it just has, yes, I'm getting it, Sharmila. Yes, so it just has one solution, right? This one. So that's why it has a unique solution. Unique solution means one solution. Is that okay? I guess this is okay now. Yes? Yes. Now let's proceed. Now let's try to plot this. And this is the first inequality that it will look like. And the second one is going to be 3, 0, and here somewhere 0, 2, right? And this will be like this, 2. So what is the common region here? This one. This is called feasible region, right? Yes? Yeah, Satish, you're right. Corner points are 0, 0, 2, 0, 0, 2, and this one is 1.2, 1.2. You're right. So corner points are 0, 0, 2, 0, 0, 2, 1.2, 1.2. There are 4 corner points. Yes, this is very easy actually. This is very easy stuff. Okay, and you can get very easy 2 marks for this. Yes, Satish, thank you very much for those. Okay, now just find Z at these corner points and tell me which one of these is giving you the maximum Z. Can you please find them? Can you please go ahead? Firstly find Z at 0, 0. That is obviously 0. Then find Z at 2, 0. Right? That is 4 into 2 plus 6 into 0 equals to 8, right? Z at 0 comma 2 equals to 4 into 0 plus 6 into 2 equals to 12, and Z at 1.2 comma 1.2 will be, can you please tell me? Yeah, Sharmila, you got it right. Sorry for that. Yeah, Mohammed. Okay, fine. So Z at 1.2 comma 1.2 is going to be 4 into 1.2 plus 6 into 1.2 equals to 12, right? Yes, and same for yes, you are right. Yeah, Adil, you are very much right. So at 2 points where 0 comma 2 and 1.2 comma 1.2, we are getting similar results. Let me redraw it again. It's kind of this is 0 0, this is 2 comma 0, this is 0 comma 2, this is 1.2 comma 1.2, right? This is the feasible region that I have extracted from here. Yes. Now at these 2 points, which points? 1.2 comma 1.2 and 0 comma 2, in these 2 points you are getting same value of objective function. That's why it has multiple optimal solution. All right, I'm going to write it over here. It has multiple optimal solution. Okay, and that is also known by the name of infinitely many solutions. Yes. Now this question is again from GATE. So very easy questions are. Is this tough? Is this stuff tough or easy? Is it tough? Is there anyone who is finding this tough? This is very easy stuff. Yes? Yes? What is the optimum value of the function? That is nothing but 12. The maximum or the optimum value of the function is 12. All right. Good evening, Preeti and Vignesh. You have joined us late. Okay. Fine. But still, okay. You're welcome. Yes, Sharmila, multiple optimal and infinitely many solutions are same. Okay. Fine. Now let's go to another discussion. Let's try to understand this, why we are saying that it's multiple optimal and infinitely many. Between this and this, you choose any one point in this line. What is this line? This is line number 2, right? This is 2x1 plus 3x2 equals to 6. You take any one point in this line, okay? 2x1 plus 3x2 equals to 6. Okay, 2x1 plus 3x2 equals to 6. Are you getting this? Between this and this is the line, right? The second line. Am I right? This is the 2 corner points that we are talking about over here. Yes? Are you following me? Yes? Okay. So just put a random value over here. Let's say x1 equals to any value you can put. Okay, x1 equals to, let's say, 3. okay, then just put 2 into 3 plus, when x1 equals to 3, no, actually it should be in between these 2 points. It cannot exceed. If I take any other point in this area, that is not acceptable. Okay, fine, are you getting this? So any point over here, so I'm taking x1 equals to 1, let's say. x1 equals to 1, okay. Now it is 2x1 plus 3x2 equals to 6. 2x1 plus 3x2 equals to 6. Okay, now put x1 equals to 1. So this is what we have. Find the value of x2. x2 equals to 4 upon 3. Yes. Yes, Satish, you are very much right. It should be in between these 2 points. These 2 points, so I have taken x1 equals to 1. So for corresponding x1 equals to 1, we are just trying to find x2. So these are these values. Yes. Now find the value of objective function at these points, 1, 4 upon 3. Right? What is that? 4x1 plus 6x2. So z is 4x1 plus 6x2. Right? So this becomes 1 plus 6 into 4 upon 3. That is 4 plus 8 equals to 12. You are getting the same value of objective function, 12, right? Right, and this is the solution that you are getting there, 12. So what does it mean? What did you understand through this? Please type in there. What did you understand? What it means that if I take any point in this line segment, I'll get the same value of objective function. That's why it says that it has infinitely many solutions. This is what it means. Yes, Satish, you got it right. That's why it's called infinitely many solutions, and that's why it's also called multiple optimal solution. Good. Yes. That's why it has infinitely many solutions. That's all. Is that good? Is it good? Yes. So this was all from today. Again, I'll come up tomorrow. We'll continue this session. We'll continue to look into other options. Till then, take good care of yourselves. I hope that I added value in your life. And this stuff is really very easy. You just need to plot the inequalities. Okay, Satish, I'll see you tomorrow because this time is up. And take good care of yourself. Be happy, give yourself some time. Try also to understand the concepts, because concepts come first, then comes the questions. All right? Yes. So I hope that you had a good time with me. Tomorrow I'm going to catch you. Till then, bye bye, take care. Or do you have any other question? Please ask me. If you have any other question, please ask me. Yeah, thank you, Shamla. Thank you for being a good student today. Yeah. If you want to ask any question, you can please ask me right now. Tomorrow's session will be at the same time, Hari. 8 p.m. You'll probably get a notification for that. Okay, then okay, it seems that you're not asking any questions, so I'll see you tomorrow. So yeah, you need to understand the concept, that's all. Okay, and I have given and I have proved why do we seek corner points, why do we get optimum solutions or even solutions in corner points. If you have not watched my older video, go back and watch it. All right, you just need not accept whatever is thrown to you. You need to ask why. It's a beautiful question, why. Yes, with this I say bye bye to you. Good night, sleep well and be happy. Okay, I'll see you tomorrow. Bye bye.